So I'm going to try to talk and teach as long as I can without losing my voice. Last time we ended at the end of chapter 6, functions and subfunctions and other things like this. And now we're going to add a new element to our programming skill, which is the element of input and output, tools for allowing input and output. So let's get started here. All right. So this is chapter 7. It's called user-controlled input and output. And that means, in essence, the person who is running your program, not the person who wrote the program, but the person who is running the program, will either be asked to input some values or be asked to direct the computer towards some values in some way as a part of the program. So after they've started running the program will actually ask them for this in some way. And one of the simplest ways to do this is using what is called the input command. So let's go ahead and take a look at the input command. Okay. So of course when you do help input, you get a lot of information here. The input prompt displays the prompt string on the screen. So input is requiring you to put in some kind of a string. Remember when we put a string into MATLAB, it requires that we have single quotes around it. So apparently we're going to use this function like input, have parentheses, and then we're going to put in a string. So let's say type your name here, close that out with another thing there, and it's going to call it input, not in out. Input, I like that, and I hit return. So what it does is it says type your name here. Okay, so I type my name there, and I'll hit return and see what happens. So right now, all I did was put in the input function, and MATLAB doesn't really know what to do with that unless I actually assign it to something. So if I type my name here, it's just kind of stuck. Doesn't know what to do. However, if I change it slightly and give it a value, name equals input, type your name here. Then when I type my name and hit return, no, that's not right. It should enter it. It did not, and I don't know why. Let's see here. I used it correctly. Let's see what I forgot. Okay. I don't know why that's not working. Name equals input, type your name here, hit enter. Type your name here. Type my name here. Why does not like that? Shouldn't have to do that, but I do apparently. So to answer it, okay, so I think what's going on, and and they do address this later on, you do have to put your name in quotes because it's going to evaluate it otherwise. If you don't want it to evaluate it, you actually have to force it not to evaluate it. So let's actually do that. If I do this command here, I can put in a number and it'll know what it is, but if I put in a string, I have to put it in quotes so it doesn't try to make a number out of it. So it doesn't look for a variable. So if I put in Jared, it's okay with that, but I have to put it in quotes. Now the way to get around that, if we go back to our help for input, here we go. Then you have to do it as an input with a little s in quotes at the end. So here is the way to do this, and I'll show you. I'll tell you what this means in a second. So we use this particular form of input if we don't want to have to put our name in quotes, I believe. The prompt is the thing that I'm going to ask it to. I'm going to say input your name here, for example. Again, I have to put that in quotes again still. Can't type. But if I tell the function input that the person who's typing is going to type it as a string by putting quote s quote, then I don't think I have to put it in quotes. Let's check and see if that's true. It's going to automatically assume that this is a string, and then it automatically calls str whatever I put in there. So a couple of different ways to do it. You can also force it to be some other type of thing. But you can also input other things. For example, if I wanted to use this to input a value for a matrix or an array, I can say x equals input, input, let's say enter your favorite array of integers in square brackets. Right? So I could just put it like that, hit enter, and then I have to put in some square brackets and enter my favorite array. Maybe it's this array here. Something like that. And it's going to enter that in now as the variable x, and it puts it over here in your workspace so that you can use it. Now there's another thing that I can do here. I can, for example, I can give my name a value. Let's say that Jared equals 43, because that's how old I am. So Jared is now going to be given a value over here. It's now a variable. If I open it up, it's the number 43. And then I say, let's put in input your name here, my original thing. I can actually type in the name Jared, and it's actually going to go look for a variable over here called Jared. And it knows that the variable Jared is 43, so it inputs, for my name, it puts in 43. So maybe I change that. Instead of calling it name, I call it age. Right? Maybe I use my age, and I want to know the age of Jared, so I type in Jared, and it's got it saved as 43. So you can use input lots of different ways. There are literally thousands of ways you could use it, but this is one. This is a few of the ways that you can use it. Excuse me. So let's make a function using this. We've got a function up here that we've not used yet, so let's go ahead and use it. Let's call this the let's call this function area of a triangle. We'll call it try area. And let's not have any input arguments. Let's have an output argument called area. And let's start this function. And it turns out that the area of a triangle is equal to 1/2 times the base times the height, right? 0.5 times the base times the height. Well, we need a base and a height. And I already decided that I wasn't going to put in, I wasn't going to have any inputs from the user at the beginning for this function, but I could ask the user for an input right here. I could say that input, I could say that base equals the input of enter the length of the base of the triangle here, right? So that could be one of my inputs. Then I could do another one called height, and that could be equal to the input enter the height of the triangle here. I have to end those both with single quote marks to spell triangle right. All right, let's see how this works. It wants me to save this, so I'll save it as try area. It says enter the length of the base of my triangle. Well, I'll say the base of my triangle is 3. Enter the height of the triangle here. I'll say it's 4. And apparently it says that triangle, well, I didn't actually send this function out here. Hold on a second. Something went funky. Let's first try this all outside of the function to make sure we're doing it all right out here. Apparently something went wrong. So enter the length or the base, base to height here. So then it gives me let's get rid of that. There we go. So then length, base, triangle, height here. Okay, so now it actually spits out the area, which is what we wanted. Maybe I don't want these to print to the screen anyway, so we'll get rid of those. And let's try this again without this suppression on this guy. And let's run it. Enter the base, and it gives me the area right there. Area equals 6. So it worked. let's look at one. Let's see here. Let's look at a little more advanced one here. Example 7.1 in the book. They're going to have you create a program that is going to calculate the position of an object as it falls down from a height, h. The distance that it falls. Actually, they're just going to calculate the distance that something falls in time. So you're dropping it in gravity, and the distance that it falls turns out to be equal to, so let's go back up here to our function, and we'll call this something else. We'll call this fall distance. And call that distance. You can write in an explanation as you please, but what this is going to be is it's going to be the distance that you free fall in gravity, and the equation for that is such the distance equals 1/2 25 times the gravitational constant g times t squared. So that's the function that we're going to do here. Of course, g is going to have a value. Which happens to be 9.8. Let's do it in feet, not in meters. Let's do it at 32 feet per second. So it's 32 feet per second per second. G equals 32. But we want to know, first of all, we want to know a starting time. So we want to know when they want us to start this in time. So we're going to have, we'll call it T1 will equal input from our user when we ask the question, what starting time do you want? And T2 will be very similar. Just copy this one. So we'll call this starting and ending time. We'll call that T2. So now we've got two things in here. And instead of having just t squared up here, we're going to have a combination of t1 and t2. And those numbers are going to have to come before this distance formula. So we'll put the distance formula last. Cut that out of there. Put that in here. But we're going to have to calculate t as well. So let's calculate t. T is going to have to equal t2 minus t1. So we can put that into our distance formula. But maybe actually we don't even want to do that. Let's not even do that. Let's actually create a chart of all these different distances. So what we need is a bunch of different times to calculate a bunch of different distances. So let's let t equal, we'll start at t1, and we'll go to t2, but we'll do it in steps of, we'll do it in 100 steps. So we'll take T2 2 minus T1, which will give us the difference between the two. And we'll divide that by 100 different pieces. And then our last step will be T2. So we'll take 100 steps between T1 and T2 by doing that right there. And then our distance we'll be calculating the distance using this array of times that we're creating here. And that'll be great. Then let's plot it. Let's plot. We want to do time versus distance versus time, however you want to think about it. So we'll do distance, we'll do time first. Distance. Plot that, put a title on it if you want, or whatever else. Let's see how this goes. What starting time do I want? Let's start with 1 second, and let's go to 5 seconds. So we've got a little bit of a problem because our time is not a square matrix. So we got to go up here and we got to use the dot time for that, right? Dot times, there we go. And dot to the squared thing, so let's see if that works for us. Starting time of 1, ending time of 5. Still a problem. We have an undefined function or variable for time. We don't want to plot time, we want to plot t. So save that, run it again. There we go. So at 1 second, we've fallen about 10 feet, looks like. 2 seconds, we've fallen nearly 50 feet. 3 seconds, we've fallen 150 feet. 4 seconds, we've fallen 250 feet. 5 seconds, we've fallen 400 feet. Right? Not bad. So that is the input function, one of many ways that you can input stuff into MATLAB from the user. And probably the simplest and easiest way to do it. Let's see, if I don't want to have an output for this, I can also erase this up here, I believe. Get a see if that worked properly. Nope. It's not proper. There we go. 1, 2, 5. So that is nice because it doesn't output all the data. If we look at what I did before, it outputted all the stuff for distance. If we come up here, it outputted the entire matrix, all 100 distances, which you didn't need. Here it's outputting the times as well, which I can get rid of by putting some semicolons after the input functions here, and then run it again. So if I want a starting time of 1 and an ending time of 5, then all it's going to output is the graph, which is right here. All it will output is this graph. So if you don't want your function to output anything, don't put anything between those square brackets at the beginning of the function. All right. So that is the input function. Let's talk about now what next? The output function. So output functions, there are many of them actually. Excuse me. The two that we're going to look at right now, it looks like, are Look at the display function first, and then the print function, the function print function. There are actually a couple of different ones. We're only looking at fprintf for now, so that's fine. Okay, so let's start with the display function. Let's clear all this out. Let's close all this stuff. Let's see, okay. Starting nice and fresh. Let's start with a very simple array of numbers. X equals 1 to 5. So we've created this nice little array of numbers, x equals 1 to 5, and we want to display it. We can do display x, for example, 1, 2, 3, 4, 5. So anything that you have over there in your workspace, you can display it. If you've saved anything there, you can display it. You can also do this. Display, and you can add some text. Put in a little bit of text here. You can say the values of x are. You got to close that out, and then you got to put in a comma and then the thing you want to display, comma x, for example. Apparently I did that wrong. Oh, yeah. I have to put in 2 display functions for that. Let's see if it'll let me do this. Won't let me do it. Excuse me. So I can display text just by doing this, and then I can display the x next. If I was doing these in a row, both in a row inside of a M file like this up here, erase this whole M file, start over, and I do display the value for x or these things, and then I put on the next line display x like that, and then I run this. Then it's going to say the values for x are and display x on the very next line. You could also do something like this. Well, that's good enough. Okay. Here's another way to do that. I forgot about this. This is a little bit confusing, but I'll explain it to you as we go here. You can also put what we just did, display the values for x are, but then we can actually put in, we can enter in x, but we have to enter in it as a what we call a num to string. We've done this before. This command, num to string, if you remember, converts a number into a string of values. And what we're going to do here is we're going to create an array by putting square brackets inside of the command, the display command, where the first value in the array is this string in quotes, and then we put a space, and the second value in the array is this num to string of x. So we've got an array of 2 strings. And if we hit enter on this, it'll actually make a nice little, the values of x are 1, 2, 3, 4, 5 right after each other. So that's just a trickier way around it. It's a little bit cumbersome, but it does the trick. Okay, so let's do a very simple little program here. This is the program they have at the bottom of page 248. It's kind of like a little conversation. We don't even have to make it a function if we don't want to. We can just have it display things for us. Display. Hello. How are you? I am a computer. Right? And then we can have it display whatever else. You know, it can make a little conversation. But you can also have it do something like ask a question. What is your name? Right? So name will equal the input from what is your name. And then once you've inputted your name, it will give you the next line. The next line is, I'm actually going to put a little pause in here, like it's thinking for a little bit. I'll put a pause of 0.5 seconds. Why not? Then I'll have it display. Display. There we go. Hello. Now, I wanted to put a name in this, right? How do I put a name in to this thing? Well, I just did that before. I created an array of hello before and another thing, one string and another thing, and the next thing was a num to string, but this time I don't actually have to put a num to string because it's already a string. I can just put in the actual variable. The actual variable is name, right? So I can put that in. Hello, name, and so on and so forth. Let's try it out. Let's see if it works. What is your name? Sure. Whoops, doesn't like that. So let's go up here and fix it. Because it's a string, we got to put our string quotes around it. Let's run it again. What is your name? Jared. Still doesn't work. How come it's not displaying? Oh, because it's stuck in a loop. Because I got to put my name in quotes. Hello, Jared. Okay. Let's try this again. I have to put my name in quotes because I didn't put it in correctly. Hello, name. Okay, so let's fix this up here. So I got that right to begin with. So I didn't want to put it in quotes up here, I wanted to put it in quotes down here. But if I want my name, if I want to input my name here, then I have to remember to put in string over here. Oops. I believe that's correct. Nope. Not correct. Let's go. We have to remember how to use input with the string. It's on page. I did it right. I just didn't. I put too much stuff. It's not str. It's just s. There we go. Got to put a comma here. Okay. So now it should work. So let's run that. Hello. How are you? I'm a computer. What is your name? Jared. And now it says hello, Jared. Right. So it's input, output, the input function, the display function. Not terribly difficult stuff. So anyway, that is the display function. And you can make this conversation as long as you want it to, have all kinds of things inputted in. Put all kinds of pauses in, all kinds of whatever. Let's talk about one more form of output, what is called the formatted print output. It's called the fprintf function. fprintf allows you to output some more complex stuff, including strings and numbers and arrays and everything else. It allows you to choose the formatting according to the code that you enter in. So here is a very simple use of fprintf. fprintf, okay. And we put in quotes, we'll call it, there are cows in the field. I don't make them up. It's not my choice. So there we go. There are cows in the field. Pretty simple stuff. However, we can also throw in objects into this. So instead of just there are cows in the field, I can actually put there are cows, and then I can insert something into the conversation. In this case, I'm inserting something that's called a floating point, or sorry, a fixed point number here. So now there are going to be this %f is going to point to a variable. Well, the variable that it's going to point to, I'm going to put at the end. The variable that %f is going to point to is going to be the variable cows. Well, unfortunately, I haven't told anybody what cows is yet, so I need to tell everybody what cows is. Cows is going to be the number 11, and then I'm going to fprintf this thing. Okay? So there are 11 cows in the field. That's what it types out. If I change the number of cows, to 32 or something like that, equals 32, then I can do the same fprintf as I did before. And there are %f for the fixed point number. It's just a variable, it's a fixed point variable. And I can use cows here again. And we'll say there are 32 cows in the field. But I can use other notations as well. I can use other formats, lots of other formats. I can point to floating points. I can point to exponential notations, decimal notations, something that's shorter, to either the fixed point notation or the exponential notation. I can look at characters. I can look at strings of characters, all kinds of things. The problem with this, as you have seen, is that after it prints to the screen, it leaves the prompt right after that line. We actually have to force this prompt down because of the formatting. So if I want to force that prompt to go down to the next line, then the thing to do is at the end of my fprintf here is to give it that command. That command here is the next line, or line feed. It's the other way. It's that one. So it's \n will give you a line feed, and it'll take you to the next line automatically. You can also do a carriage return. You can also do a tab. You can also do backspaces. So let's say we want to put a tab in the middle of this. Let's say that let's actually do a carriage return right here, for example. If I do a carriage return, it's \r, then this is what it's going to look like. There are 32 cows, carriage return in the field. Right? Let's do a line feed in the middle and see how that's different, if it's any different. They're very similar, so it may not be any different in this case. Yeah, there are 32 cows in the field. But I can also do something like a tab. You can put a tab in the middle here. There are 32 cows, and it puts a big tab space in the field. And so there's lots of things you can do formatting-wise using fprintf that you can't do otherwise. Excuse me. All right. This is a confusing one. Often confuses people. Let's do a new phrase here. Now let's use the same phrase. Let's get rid of the tab. But let's pretend we can have fractional cows. So I can have 3.5 cows, for example, or something like that. So let's rename our function. Let's go to cows. And let's call this equals 3.5. So it's going to be 3.5000000, just like it was 32.00000, right? Well, this gets a little bit obnoxious. What if I don't want that many numbers hanging out in there? I want to change this to a certain number, a certain amount of numbers. And we can actually also choose that. It turns out that there are 8 digits, 1, 2, 3, 4, 5, 6, 7, 8. And I can choose how many digits I want to display. So if I go in here to my %f, I tell the computer that there are 8 total digits, and then I tell it how many digits to display. I want it to display just 2 of them. And it shows me 3.50. Now that may not look like 2, but what it's doing is it's doing 2 digits beyond the decimal place. So I can also choose 1 digit beyond the decimal place. 8.1. So it's now 3.5. I could also do, I think, 8.0. Let's try 8.0. So it's going to round up. It actually takes the first digit and rounds up. And it always rounds up, actually, it turns out. So you can actually make it a much more friendly looking thing here. The problem is that it's going to leave this huge space because of the, I believe because of the 8s that's in there. It's leaving 8 spaces. Let's change this. Yeah. So the first one is telling it how many spaces to leave. The second one is telling it how many digits to round to after the decimal place. So if you don't want that much space in there, don't leave that much space. If we went up here to this one up here, we can actually leave it as 0.2. And it leaves less space there. So that's nice. So that's the thing that's confusing is the first number is telling you actually how many digits to leave open for that number, or how many spaces to leave open for that number. The second one is actually telling you how many digits to round to after the decimal place. Okay, let's see what else we can learn about this. Trying to think of something else here that's of use, of interest to us. I can't really think of any else, other things to use with fprintf, formatted output. Let's take a look at an example here. Let's see, what are they doing in this example? Oh, they're actually doing the same example we just did with the free fall, but they're just doing it with fprintf. Okay, let's do it. It's kind of boring, but we'll do it anyway, I guess. So, the example went something like this, where we asked for some input. So let's go back up here to our function up here. Say input equals, sorry, not input. T1 equals input, there we go. We want to ask them the question, start time, and take the same thing, copy it from here, paste it, T2 equals input, end time. Then we do our calculation. Our calculation looks like we need it's going to be distance equals 0.5 times 32 for this, and times the time. And remember that the time was this array. Time equals T1 to T2 minus T1, all divided by 100. So 100 of these. Let's not do 100. Let's do 10. We don't want to display 100 things. All right, so time is this thing, distance is this thing. So we're getting inputs from our user, making time and distance, and now let's use fprintf to create a table, for example. We can actually create the table, create an array of the two things, time and distance. But if you do that, we just make a table of time and distance. May not be so clean. Let's take a look. Time and distance. So let's look at this here. Run this. Start time 1, end time 5. So the table looks a little bit just messy. First of all, it says table up here, which is just kind of dumb. It's also not very clean because it has all these digits in it we don't need. It's just kind of messy. So instead of doing that, let's use fprintf. Let's close off this here, and let's use fprintf, and let's clean it up using our formatting that we can use. So we have fprintf, and let's say data for free fall distance. Sounds good. free fall distance from, so let's do, we're going to put in some seconds here. And the seconds that we're going to put in, we need to put them in a certain format. We'll just put it in as a, let's see, the format will be we'll just take the time T1. So we're going to do a backslash, no, we're going to do a % sign. Let's do a 3.1, and let's take that as a fixed point data. Distance from that in many seconds to, let's go to percent 3.1 f seconds. So I've got two things that I'm going to put in this time, it turns out. Two numbers I'm going to insert in here, so I have to put them both in this here. Let's see. G. I'm going to put in T1 and T2. I believe that will work. Let's try it. Let's run it. Start time is 1, end time is 5. Oops. Oops. Can only do one of those, so I'll have to do 4. So if I can only do one, I'll just use time. So there we go. Let's try that. Start time 1, end time 5. Goodness gracious, what did I do? Oh, it's got to be in quotes. Try that again. So many ways to make mistakes. Goodness, it still doesn't like it. What did I do wrong? I did that right. Didn't I? Oh goodness. Oh, I see what I did wrong. It's a math thing I did wrong. I want to put the number in here, T1, T2 minus T1. But I don't have a variable for that, so I have to make a variable for that. So we'll call it T equals T2 minus T1, because I need to put that number in there. So I just put in T. Now let's try it. There we go, start time 1, end time 5. One of these days, it's going to work for me. What did I do wrong? I'm using the correct fixed point notation. T is a value, a single value. What's that? Oh, I misspelled fprintf, didn't I? Thank you. There we go. That was probably my problem from the beginning. Start time 1, time 5, there we go. So it's got it in there for 4 seconds, but I don't want that to prompt after that, so let's go ahead and fix that. Let's put a carriage return at the end of this. So backslash line feed end or something like that, right? So then I go start time 1, end time 5. Okay, so now I want to put in that actual data, which I didn't do yet. So let's go ahead and let's do an fprintf of this table here. So down here, print table to screen. Should be doing more of that. I'm not very good at doing my commenting today. So let's do an fprintf again. Fprintf all the way through. So fprintf, what I want to print is the actual table, and I want to choose how many digits I'm going to keep in this table. In my seconds column, I'm going to keep 0. I'm going to have 0 digits after the decimal point. So I do 8.0f, and then I'm going to do a space for the next column here for the next column. I'm going to do a %. I'm going to give myself a little more space on the second one, and I'm going to do 2 digits on this one for the distance, 2f, and then I'm going to go ahead and close it off. I'm going to do a line feed at the end of that so that I don't have the stupid thing in my way. And then I'm going to actually plug table into that right there. Because there's 2 of them, there's 2 columns in the table. This will do both columns, one right after the other. So start time is 1, ending time is 5, and there's my data. Let's see here. I didn't read the % because I didn't write the %, so there we go. Let's run that. Start time 1, 5. There we go. So there's my data. Notice that it shifted it over a little bit because I told it to leave 8 spaces. Then I put in my data here, and it's rounding all of that data. So that's not all that great. It's rounding it to 0. So let's change that to let's do 2 on that one as well and see what we get. So there we go. Tenths of seconds. So these are seconds essentially. You have 0.1 second, 0.2 second, 0.3 second, so on, and distances. It's not doing it for 4 seconds, obviously. It's doing it for 0.4 seconds. But that's okay. All right. I think we're getting close to the end here. I would like to go a lot more, but my voice I don't think will stand much longer. There's a couple of other things that they're going to cover here. One is the sprintf. Excuse me. And then there's also graphical input. So you can click on a graph and get input. Then reading and writing data from files. And then debugging code, which is... So, sprintf function. Similar to the fprintf function, except for one little thing. And that is, let me see if I can find an example of this. Are they even doing an example of this? Or are they just telling you that it's true? Oh, here it is. Yeah. Okay. So let's actually just change this one. We could do this whole other one, this whole other example with this, but I'm just going to change this one and show you what happens. Notice that when we created this table down here, it just printed it to the command window. And nothing showed up over here. We'd already saved it as table, but nothing shows up over here in the workspace. But if we use sprintf and do the same thing, start time 1, end time 5, we get the same thing over here, but it actually assigns it a variable. So it gives it a space in the workspace. So it's saving this over here in the workspace. And that can have great advantages. Not only will it print out the answer, but it saves the answer so that it can be used later. So that's the sprint, and that's just another way of putting something to the command window, but it also saves it as a variable. So those are all the outputs that we're talking about in this chapter. The next thing is another kind of input, which is kind of an interesting one. So this one allows the user to click on the graph, and then it will take the point at where that user points on the graph or clicks on the graph, and it'll input that into some variables. And this is what it looks like. So let's build a graph first. Let's build a plot of from 1 to let's plot from -5 to 5 in steps of 0.1. Let's plot that against x squared. We're going to have to name x first. Let's do that. X equals paste. And let's plot x versus x squared. So pretty simple plot. So it's just this parabola that we've plotted. And now what I want to do is I want to do this. I'm going to say that I'm going to give values to big X. We'll call it x1, comma x2, comma y2, comma y1 rather. There we go. x1, y1. We need to put it in square brackets because it's going to be an array of two numbers. It's going to be this is going to be like a ordered pair of numbers. And this is going to be equal to G input or graphical input. And you're good to go. So what it does is it brings up the graph, and then when you bring your cursor over the graph, it brings up this little bullseye. So you can pick any point you want anywhere along the graph. I'm going to pick this point right here. Wherever. How come it's not working for me? Should work for me. Let's see. Oh. Since there's one other thing that I have to do if I want to just click once. So what it did is it took every click that I made, which was quite a few of them, and it made an array of points. So here are all the X points that I clicked, here are all the Y points that I clicked. So the first point that I clicked was 2.6 on the X-axis and 20.16 on the Y-axis. However, if I use the same function, the same command, and I tell it that I only want it to click once, then it'll only allow me to click once on the graph. Okay? And then it'll input those values for X and Y on the graph. So this can be a very useful thing if you have a graph that you're creating in a function or in some kind of program, and you want the user to select something from that graph for the next part of the program. This is exactly how GUI interfaces work, graphical user interfaces. What they do with Windows, for example, is they create all these little buttons on your screen, and each one of those buttons is in a location on the screen. And when you go and click on that location, the program goes back and it asks the computer, what is at this location? And it says, well, that's where the cancel button is. That's where the close button is. That's where the, explode my computer button is, or whatever. And then it tells the computer what to do from there. And so now we've made the first step into graphical user interfaces. This is how it works. Is it uses this little function called a G input, a graphical input. It knows where the mouse is. When you click there, it sends those coordinates back to the program, and you can use those coordinates to do whatever you want. Okay. I'm getting tired of talking with this voice. The last of the last. We have this whole section at the end about reading from files. From data files, and there are lots of different data files out there. Just about any file can be read like a data file, because all files are just data files. But there are certain files that we read through specifically as data files, like text files and Excel files and other files like this. But any file can be read. A picture file, like a JPEG, is just a file of numbers, and you can read it number by number if you want. A Word file is just a file of numbers. Microsoft Word reads that file and turns it into a document. But MATLAB can read that file and read it as just the numbers that are in the file. And so that's kind of what they're teaching us here. It's not all that hard. You're going to use, there's a couple of different functions you can use. One of them is the UII import, which is for importing different files, any kind of file really. You can import any kind of file as just a file of numbers, but there's also one where you can read specific files. For example, you can import data using XLS read, which is for Excel files. XLS stands for Excel. So you can read files using XLS read, or you can write to an XLS file using XLS write. You just need to know the file name, and it'll read it or write it. It's pretty simple stuff. My voice is fast leaving me. I'm not going to be able to talk much longer, so we won't go into anything else. I think I've given you everything you need to know to do the homework, and I'm going to leave it at that before my voice completely dies. So, have a great week, and I will be available as you need me.